Hello, my name is Jim Mullaney from SciTech Process Solutions. Today is Monday, April 2nd, 2018. Hope no one had any April Fool's jokes played on yesterday. Today I'm doing a video source inspection on a semi-tool spin rinse dryer, but actually this is not for the customer. This video demonstration really is for the rotors and the inserts we built for another project. For the privacy of our customers, we do not give their purchase orders or their name online. This PO number was A182-60MB. This was kind of an interesting order because what we had to do is design rotors that accept the Integris A182-60MB cassette. That's a 6-inch cassette, and it's balanced 0 to 25. So what I'm going to do is I'm going to go through and videotape different substrates and inserts that all work with this rotor that the customer did purchase. For the convenience of the video, we currently have a 30-second rinse, 30-second dry, then a 200-second dry 2, which is low RPM. What I'm going to do is when it goes into the dry 2, we'll stop the video, and that way, and then we'll start it right when there's like 5 seconds left at the end of the process. The reason I'm doing that is that we're going to run 5 different tests here, and this video would become a half hour long, and probably people wouldn't want to watch it that much, and nothing happens between the 210 seconds. So what this customer's done is they purchased the rotor for those. They've also purchased an insert, the SciTech insert design, for the A182-60M cassette. This is actually P for poly. So I'll show you how that works. They also purchased inserts for, they made a cassette that mimics the outside of that poly cassette I just showed you, but this runs 3.1 by 3.1 substrates. And they also purchased inserts that will allow the same rotor to run this Integris cassette, which is a A102, and it's for 2-inch by 2-inch squares. This was a multiple part order. They purchased 3 brand new rotors. They purchased 3 of the inserts for the smaller cassette. They purchased 3 inserts for their custom cassette that mimics the A182-60M, and they purchased 2 inserts for the blue poly cassette I showed you. I've done full testing on all the rotors and all the inserts, so for the ease of this video, I'll just run 1 rotor with 1 each of the inserts with the substrates. So to start off, I'm going to go ahead and run the traditional 6-inch cassette. This rotor is balanced 0 to 25. This is the heaviest load this will see. I'll go ahead and run the second process with 1 wafer, and you'll see. So you simply load and hit start. The way semi-tool works is traditional is a 2-step process for drying. You have your rinse time, which the customer can put whatever they like. Dry 1 is the high RPM dry. It's meant to sling the water off of the substrate, the cassette, and the rotor. And then dry 2 is the low RPM, where you use centrifugal force, the heating blankets, and the N2 heater to dry the substrates. You see it's running nice and smooth with a full set of wafers. We're going to ramp up now to approximately 2,000 RPM. And you can see the digital meter ramp up. There we go. Right around 2,000. You can see nice and smooth, looks good. And we're about to ramp down to dry 2. There we go. Now it's ramping back down to approximately 600 RPM. The 328 controller doesn't have as fine RPM control as the newer digital controllers. So you have to kind of look at the marks on the controller, the RPM meter, where it's at. And we're ramping down all the way down to, it'll ramp down to 600. As you can see, it's running nice and smooth. We'll go ahead and turn the video off now for the next 3 minutes, and we'll turn it on with about 10 seconds to go. Okay, we're down to 1 second, 0 seconds, and we're ramping down. What I'll do is I'll feel for the warm end too, and I'll check the substrates, make sure they're dry. With the SG controller, 9 means process is complete, and once it spins down, the rotor stop positioner in the back, which is a piston, will push up and upright the rotor to what we call home position, which is 12 o'clock. And in a second, There we go. 0 means total process complete, door should be released. It is. Feel for the hot end too, that's LPP for low pressure purge. Wafers are nice, look good. I'll put this cassette down. And now I will bring the same cassette model with only one wafer. But before I start, I should have done this in the beginning. I want to talk about, that's why many people around the United States, around the world now, come to SciTech for our insert design. Traditionally, at Semi-Tool in the past, if you want to run different substrates, you had to buy different rotors. These rotors are expensive, and they take 4 bolts or a single bolt, and you have to remove them all the time. They could get banged, and they get out of balance. So with SciTech, we have different insert designs where if a customer runs multiple processes or substrate types or sizes, we then build a master rotor for the largest substrate or cassette, and then we downsize, as you saw in this case, for 3 other substrate sizes. We can do this for people that run a 4 and a 6-inch fab. If they want to run a 6-inch rotor and buy a 4-inch insert, they do 8, 6, 4. We've done one university did 6, 5, 4, 3, 2. That way one rotor could run all processes. Okay, so I'll go ahead and start this one in the same sequence here. On the inserts themselves, I won't go 0 to 25 because this shows you the heaviest load, which is 25 silicon wafers, and the lightest load, which is 1 wafer. All of the inserts I've tested, 0 to 25, all fall within that middle range, so there's no reason to run all the different tests. They've already been done here, at least for the value of this video. Now we'll go into the high RPM dry. If there's a balance issue, traditionally it's in the high RPM dry. Okay, ramp it up nicely. There we go, 2,000 RPM. Nice and smooth. Looks good. And we're going to ramp back down in the next step in 3 seconds. And here we go, ramping back down. As you can see, nice and smooth. As it ramps down, everything looks great. Okay, we'll turn the video off again, do the same thing at the end of this process. Okay, we're down to 6 seconds of this process. As you can see, it's running nicely. It's at about 600 RPM, probably 625, something like that. And we're going to go ahead, and as I already spoke about, 9 means process is ramping down. 0 means the door can open. So you see the door is locked right now until the 0 comes up. So I just showed you 2 videos, or in this video, of this machine running a full cassette of 6-inch wafers and then 1 wafer 6-inch. Now I'll show you the different inserts designs. Okay. Everything looks good, nice and dry. Alrighty, so now you saw that. Now imagine a customer wants to run their A182 cassette. So they simply take the insert and you slide it in. That's how fast you change wafer sizes. Take their cassette and load it in. So now I've, within less than 10 seconds, have changed substrate sizes. Run the same process. We'll do the same thing again. When we go into the low RPM dry, I'll talk about a couple other tools we do and some other projects at SciTech. You can see it's running nice. Okay, we're going to go into dry 1, which is the high RPM. Beautiful, nice and smooth. So while this is doing this, we'll ramp after 30 seconds, we'll ramp down. I'll talk about a couple other things. At SciTech, we do quite a lot, especially over the last year, of customers' rebuilds. In this case, a customer purchased this machine from us. Again, it's not for this rotor, but it's for a different process. And that's going to ship out today too. But quite a lot of customers send us their machines that are 15, 20 years old, even 5 years old, and we offer a complete remanufacturing process. Here's an example. This is a customer that sent theirs in to us. It was just rolled into wet test. It's already been through dry testing. This happened to be a double stack. The second head's coming in. We took their system all the way down to the ground like it was ours and have done a complete refurbishment of it. As you can see, it looks beautiful. It runs great. Once I do testing of this, it's going to go into the double stack configuration. But we do other tools. Here's a Brewer Science CE 100 that's going to ship probably later today. This customer runs 6 and 8 inch wafers, and we did the complete refurbishment of this system. It looks beautiful, almost looks brand new, and we're going to videotape this later today. We also do photoresist pumps, we do etchers, ashers, a lot of other tools. We do quite a lot of the Entegris box washers. You might hear it back there running. We have one in test. We have a back order of 5 systems right now, and now customers are actually placing orders to get in line for our next systems, even if we don't have them yet, because they know we buy between 6 and 8 a year, between 6 and 8 a year. So it's a very good market for us. All right, I'll come back here. So now we'll turn off the video. We have 130 seconds to go. Nothing can really happen, and I'll turn it back on with about 10 seconds again. All right, now we're down to about 9 seconds here. See, we're running nice and smooth. Okay. Alrighty. Second, I'll open it up. There we go. Let's see the wafer substrates. There you go. Nice and dry, nice and warm. So, let's say now I want to run a different size substrate. I simply take out my insert, slide it out, and take my new insert and simply slide it in. Let me get the cassette. This customer wants to run H-bar out specifically on this cassette, so we left it that way. I load the wafers, nice and easy, and do the same thing. You can see it's nice and smooth. Well, high RPM is where we always like to see the balancing at. What I'll do when we go into dry one, I'll talk a little bit about quickly our semi-tool support. Okay, ramping up. There we go. Ramped up to about 2,000. Very nice. Looks good. Okay, we'll let this process go through. So to talk about our semi-tool support, if you go to our website at scitechprocess.com, we are the U.S. leader in semi-tool remanufactured systems and spare parts. We offer for the Richard dryers the S model, the F model as in Frank, and the traditional ST. On our website, on the left-hand side, you'll see the first 7 buttons. The first 3 buttons are for all 3 different type machines. The next 3 buttons are for the different spare parts for each machine. And the 7th button is all the spare parts we support for the SST, Spectrum, SAT, and so forth. If you go to our website, we offer 100% spare parts on this tool. We can do motor rebuilds. We can do controller rebuilds. We do new amp, new motors. We do new heater blankets. We do new valves. We do new process switches, new windows, new door seals, new everything. So on all 3 versions of the semi-tool rinse dryer, we offer 100% spare parts. One of the things that you'll really like to see too, if you go to our website, it's called the Slick Device S1. It's the replacement controller for the S and F model. It's the state-of-the-art graphical controller. It's the best controller available in any spin rinse dryer worldwide. And we have customers now buying this every single week. We're selling multiple controllers, and they're retrofitting out their fabs. For what our new S1 controller does, it allows you to take an existing technology rinse and dryer with our enhanced intelligent controller, make it like state-of-the-art, and hopefully you'll have another 20 years available on your rinse and dryer for the cost of a controller versus spending another $65,000 on buying a double stack. Okay, I'll go ahead and turn the video off again. No reason to watch this for the last 2 minutes, and we'll turn it back on for the last process. Okay, video is back on. We're down to 6 seconds in this process. Low RPM low RPM ramping there, and we're going to slow down. 9 comes up, and we'll take these out in a second. Alrighty, there we go. Take the substrates out. Looks good. Simply remove the rotor to change wafer sizes. Okay, so for my last one, the customer also runs 2x2. Let's say I want to run those. I take the insert for that one and slide it in. Nice and easy. Take the cassette with the 2-inch substrates. Load it in. Just like that, and now you've changed wafer size. We'll go ahead and do rinse and dry one, and then we'll turn the camera off again like we did for the last 210 seconds. Okay, another 5 seconds, we're going to ramp up. That's what I want to show you, the high RPM. Okay, ramping up now. 2000 RPM. There we go. So now we'll go ahead and run through this process, and I'll turn the camera on about 10 seconds ago, and we'll remove the wafers. Alrighty, we're down to 7 seconds there. Let's watch the ramp down. We'll go ahead and take these substrates out and check them. Then I'll do a quick recap of this demonstration today. Alrighty. Okay, let's take out the cassette. Wafers look good, and simply remove the insert. Alrighty, so to recap, as you can see at SciTech Process Solutions, we can build master rotors or rotors for a standard Entegris cassette, and we have the capability of designing through our engineering work and our balancing tools different inserts that immediately, as you saw, it takes less than 10 seconds to change substrate sizes. This customer actually ran 25 silicon wafers, 0 silicon wafers, and then 2-inch, 3.1, and 4x4-inch substrates, all with, as you saw, less than a 10-second change out by insert. Again, we are the world leader in semi-tool remanufactured systems, along with our S1 and F1 slick device controller. And if you go to our website, we offer 100% spare parts on all of the semi-tool spin rinse dryers. If you have any questions, feel free to call us at 916-797-9000. And also this year, feel free to stop by and see us at SemiCon in the Moscone Center in California in July. Thank you. Have a great day.